This is my first proof. We have this figure on the right, and what's given is that side AD is congruent to side DC, and that AB is congruent to side BC. And we need to prove that BD is an angle bisector of angle ABC. So first we can mark that side AD is congruent to side DC, because that is given. And side AB is congruent to BC, because that is also given. And we can mark that side DB is congruent to itself by the reflexive property. All of this leads to that triangle ADB is congruent to triangle CDB by the side-side-side conjecture. And this means that angle ABD is congruent to angle CBD by CPCTC, meaning that BD is an angle bisector of angle ABC by the converse of definition of angle bisector, since the definition of an angle bisector is that it divides an angle into two congruent angles. So if we know that the angles are congruent, then that means it's an angle bisector. For my second proof, we have a different figure on the right, and what's given is that V is the midpoint of both RS and TQ, and we need to prove that RQ is congruent to TS. So first, we can mark that RV is congruent to VS by the definition of a midpoint, since the midpoint divides a segment into two congruent segments. And we can also mark that TV is congruent to VQ by the definition of a midpoint. And we can mark that angle RVQ is congruent to angle TVS by the vertical angles conjecture. And this means that triangle RVQ is congruent to triangle SVT by the side angle side conjecture, thus meaning that RQ is congruent to TS by CPCTC.